Adam and Boudin are playing a game of Bow-C. Each wants their ball to land closest to the jack ball. Their positions of Adam's ball A, Boudin's ball B, and jack ball J are shown in the diagram. What is the distance from A to J? So I believe these are a bunch of Pythagorean relationships. So this is your standard 3, 4, 5 triangle. So this is going to be 25, the distance from A to J. And you could have done that with Pythagoras also, which I am certain you know how to do. So that's 25. And then you just keep going like that, I guess. For part B, what is the distance from B to A? Again, Pythagorean relationship. BA squared plus 15 squared is 39 squared. And then when you solve this, you get BA equal to 36. Determine whose ball is closest to the jack ball, Adam's or Boudin's. So Adam's ball is 25 away. And then I guess we just have to calculate from B to J. So again, Pythagorean relationship. BJ squared plus 25 squared is 30. AB squared. I guess we have to figure that one out. And we did already. That's 36. So that's 36 squared. And then when you figure this one out, you get BJ is equal to approximately 25.9. So 25.9 is here. So B to J is 25.9. A to J is 25. So obviously A is closer. So the answer here would be Adam. When the numbers 25, 5, and 29 are taken in pairs and averaged, what are their averages? Okay, so 25 plus 5 divided by 2, that's the first average, and that's 15. 5 plus 29 over 2, that's the second average, and that I believe is 17. And 25 plus 29 over 2, that's the third average, and that is 27. So those are the averages when taken in pairs. When the numbers 2, 6, and n are taken in pairs and averaged, the averages are 11, 4, and 13. Determine the value of n. So 2 plus 6 over 2, that's 4, so that takes care of this guy. 2 plus n over 2, I believe that's going to be the 11. So when you solve this, you get n is equal to 20. And let's just do the last one. The last one would be 6 plus n over 2, and that is most likely going to be the 13. And when you solve this, you get n equal to 20 again. So we were consistent, and therefore we know that n is equal to 20. C, there are 3 numbers a, b, and 2, each number added to the average of the other 2 numbers. The results are 14, 17, 21. If 2 is less than a, less than b, determine the values of a and b. All right. So our equations are a plus b plus 2 over 2, b plus a plus 2 over 2, and 2 plus a plus b over 2. Now, we have to match these. They didn't tell us which one is which. So because of this, I'm going to guess that the smallest one is the 14. And then the next one in terms of size is A, so that's going to be 17, and then this is 21. So it's probably not that difficult to figure that out. And then you just solve these. We got 3 equations, 2 variables, so more than enough equations to solve. So here we go. I'm just going to concentrate on this one. This is going to give me A plus B over 2 is 12, I believe. So that means A plus B is 24. And then I guess I can substitute it into any one. I guess I'll substitute it into this one. First, what I'll do is multiply that by 2. So I get 2b plus a plus 2 is 42. So this makes it, I'm going to break it up. B plus a plus 2 is 42. And then this b plus a is 24. So then I can just put that in. And then when I solve this, I will get, I believe, 16. Yeah. And then put that in there, and that will give you A is 8. So there you go. A is 8, and B is 16. The diagram shows one of the infinitely many lines that pass through 2, 6. A line through 2, 6 has slope -3. Determine x and y intercepts. So y is equal to mx plus b, where m is the slope, and in this case it's -3. So it's 3x plus b. Now we can use this point to solve for b. So when y is 6, that means x is 2. So that means that b is equal to 12, I believe. So that means that equation is actually y is equal to -3x plus 12. And then to get the y and x intercepts, you just set the other to 0. So when you set x to 0, you get y is equal to 12. So that would be this point here, 0, 12. And then when you set x equal to 0, when you set y equal to 0, you'll get the other intercept, which would give me 4, I believe. Yeah. So that means this point is, that point there is 4, 0. So there you go. Those are the intercepts. 4, 0, 0, 12. All right. Part B says another line, same point, has slope m. Determine the y and x intercept. So this time they're just giving you m. So let's solve for b. Again, using the same point. 6 is equal to 2m plus b. So that means b is equal to 6 minus 2m. So that equation is basically y is equal to mx plus 6 minus 2m. And then in the same way, you calculate the intercepts, set x equal to 0, and that would give you y is equal to 6 minus 2m. So this point now is 0, 6 minus 2m, this point Q. And then set, let's see here, set y equal to 0 and solve for x. So that would give me 2m minus 6 is equal to mx. So therefore x is equal to m minus 6 over m. Wait, hold on. Sorry about that. It's 2 minus 6 over m. Yeah, okay. All right, so that means that this guy is 2 minus 6 over m, 0. Okay, great. 2 minus 6 over m. Okay, so part C says another line through 2, 6 has slope m, crosses at P and Q. Determine the two values of m for which that triangle has an area of 25. Okay, so triangle POQ, that has an area of 25. So it's 1/2 base. This is the base. So that's basically my x-coordinate, which is 2 minus 6 over m. And then this is the height, and that is 6 minus 2m, I believe. 6 minus 2m. Okay, and they tell me that's 25. All right, so let's solve this and solve for m, I guess. Okay, great. So let's first multiply through by 2, and that would give me 50. And then let's expand this. So 12 minus 4m minus 36 over m plus, I believe, 12. Yeah, and then put everything on one side. So we get 0 is equal to 4m plus 36 over m plus 26, I believe. And then multiply through by m. And we're going to get 4m squared plus 26m plus 36. Let's see here. I think we can divide through by 2. And then we should be able to factor this. Let's see if I can. 2m, m, 9, and 2, I believe. Put the 9 here, the 2 here, plus, and there you go. So m is either -2 or -9 over 2. So there you go. Those are the two values of m that satisfy this equation. In town A, 5 students are standing at different intersections on the same east-west street as shown. The distances between adjacent intersections are given in kilometers. These students agree to meet somewhere on the street such that the total distance traveled by all 5 students is as small as possible. Where should the students meet? All right, so I don't know where the students should meet, but I'm going to make a guess. I'm going to say it's somewhere here. let's say it's here. We'll just call that point P. So from this point to P, I'll call X. And then from P to this point, obviously that's going to be 4 minus X. Yeah. All right, so now let's see here. From A to X, A to P. That's going to be 1 plus 2 plus X. So 3 plus X. That's the distance. From B to P, I believe, is 2 plus X. From C to P, that is X. From Denise to P, that is 4 minus X. And then finally, from Ernie to P is going to be 7 plus 4 minus X, so that's 11 minus X. And then we want this total sum. So that's going to be, let's see here, 5 plus 15, so 20 plus X, I believe. Yeah. And we want this to be small as possible. Now, X has got to be a positive number. So, well, X has to be greater than or equal to 0 is the best way of saying it. So if we want this to be as small as possible, we want X to be 0. So therefore, this would be equal to 20. And therefore, that means that point P is right there. It's sitting exactly where Carla is. So that's it. I guess that's what they want. All right, next part. In town B, there is an even number of students. The students are standing at different intersections on a straight north-south street. The students agree to meet somewhere on the street where that will make the total distance traveled as small as possible. With justification, determine all possible locations where the students could meet. So we have a situation that's going north-south, and there are how many? Even number of students. So I'll let the number of students be equal to 2n, since 2n is always an even number. So I'll put the first student here, the second student there, third student there, and then all the way down to the last student would be the 2nth student, and then the 2n minus 1 student, the 2n minus second student. So for example, like if 2n was whatever 50, this would be the 50th student, this would be the 49th student, 48th student, like that. I'm just giving an example. Okay, so now we got to figure this out. So here we go. I don't know where that point is, but I'm going to just put it here, just somewhere in the middle would be my guess. Now the distance from the first student, so the distance from the first student to P, so I guess from here to here, and the distance from the 2n student, this guy, to P, so the distance from 2n to P, if you add those distances, it will always be a constant, no matter where P is. I hope that makes sense. So no matter where I put P, if I add the distance from 1 to P and from 2n to P and add them, it will always be a constant, and it actually equals the total distance, regardless of where P is. So I just put constant. Now something interesting happens. If you do the same thing using now 2 and 2n minus 1, from 2 to P and 2n to P, so the distance from, I guess, 2 to P and the distance from 2n minus 1 to P, if you add those, they also give a constant value. And regardless of where P is, that distance will be this distance, whatever that distance is. And in a very similar way, I'll just do this one more time because I think you get the idea. The distance from 3 to P and the distance from 2n minus 2 to P, that's also going to be a constant. Regardless of where P is, that distance is going to be from there to there plus there to there, and that distance is going to be a constant regardless of where P is placed. So if you just keep doing this, you will get to a conclusion that P must be located somewhere between the middle two students. And that will satisfy this condition that we want the distances to be as small as possible when you add them all up. Now, if there's 2n students, the middle two students are the nth student and the n plus 1 student. And therefore, if you continued this ... what we did up here, dn to p plus dn plus 1 to p, those distances will also be a constant. So that means you can place p anywhere between student n and student n plus 1. And if you do that, you will satisfy the conditions of the question.